I'm going to call this example 5. These are pi over 12 questions. We are going to figure out the exact value of things on our pi plate right between the 0 and 30 degrees, or right between 60 and 90 degrees. Sort of like the 15-degree family and the 75-degree family. And the strategy that we're going to use is here. So we're going to use the pi over 3, the pi over 4, and the pi over 6 families that we already know on our unit circle. And we're going to add or subtract them to get the pi over 12 family. Now, each of those pi over 3, pi over 4, and pi over 6 families, I've changed them so that they have a denominator of 12. And so in A, if I wanted to find cos of pi over 12, I have to figure out, is there a way I could add or subtract them to get pi over 12? And there's actually two different ways. I could either take 4 pi over 12 and subtract 3 pi over 12. That would give me 1 pi over 12. Or I could take 3 pi over 12 and subtract 2 pi over 12. That would also give me 1 pi over 12. So for this first one, we could use these ones. Later, we're going to find out that we can use any coterminal angle or any family member on our unit circle to figure these out. Okay. Be careful with your notation. We want to find cos of pi over 12. I write an equal sign, it's equal to cos, and then in brackets, obviously 4 pi over 12 minus 3 pi over 12 is equal to 1 pi over 12. But I'm wanting to make sure that in my notation I have cos of pi over 12 equals cos of, this is equal, and then I'm like, okay, well 4 pi over 12 was pi over 3, 3 pi over 12 was pi over 4, so this is equal to cos of pi over 3 minus pi over 4, and above the pi over 3, I'm like, okay, I'm going to make that my alpha, and I'm making the pi over 4 my beta, and so I have a cos alpha minus beta, which allows me to write it as the right-hand side for my formula sheet. So if I write that as the right-hand side, it gets bigger, because then I'm going to have cos alpha cos beta plus sine alpha sine beta. But now this is just a pi plate question. All of those are on your pi plate. You know what cos of pi over 3 is. That's a half. You know cos of pi over 4. That's root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. So our next step is we can just replace each of those with the values from their pi plate. Use your fraction rules. How do you multiply fractions? Multiply the numerators, multiply the denominators, and write your answer as a single fraction. So we're going to get root 2 plus root 6 all over 4. So we just figured out the x-coordinate at 15 degrees, or at pi over 12, without a calculator, using these new formulas that we were given today. If you have one in degrees, it's the same idea. Is there a way that I can add two values from my unit circle to make 75 degrees? Well, I definitely could use 30 degrees and 45 degrees. And the reason these are called pi over 12 questions, well, 75 degrees technically is 5 pi over 12. So these are all of the pi over 12 angles that are possible. And this technique is basically opening up. I could give you anything pi over 12, and you should be able to figure it out. So since I can write 75 degrees as 45 degrees plus 30 degrees, 45 degrees would be my alpha, 30 degrees would be my beta. I go to my formula sheet, and I see that my sine alpha plus beta formula is sine alpha cos beta plus cos alpha sine beta. All of those are on your unit circle. And you can just plug in the values. Sine of 45, root 2 over 2. Cos of 30, root 3 over 2. Cos of 45, root 2 over 2. Sine of 30, 1/2. How do you multiply fractions? Multiply your numerators, multiply your denominators. And you'll get root 6 plus root 2 all over 4. One of the things as a pattern you're going to notice is that for sine and for cosine, all of your pi over 12 families have a root 6, have a root 2, and are always going to be over 4. Sometimes the root 6 is positive, sometimes the root 6 is negative. Sometimes the root 2 is positive, sometimes the root 2 is negative. So you have a bunch of different options based on positive and negatives of what could possibly come out as a result. So the third question we're going to do is 17 pi over 12. And I'm going to hand out a scrap piece of paper to everyone. And you can take out your pie plate if you want. No, you're not allowed to do the math on the other side. And what we're going to do is we are going to figure out two things that add up from your pi plate using the pi over 3, pi over 4, pi over 6 families, and anything coterminal with them, and any family member possible. And you need to find two of them that either add or subtract to 17 pi over 12. And as soon as you find one, you let me know, I write it up on the board, and then that one's not allowed for anybody else to find. There is a million different possibilities, some easier than others, and everybody has to find a different one. So if you want to be quick, you can find the easy one first before somebody else. But once one is found, you have to find a different one. So for example, does 5 pi over 4 plus 7 pi over 6 work, or doesn't it? You're going to have to find two things that add to get you 17 pi over 12. I'll write them all up as people find them. We've got our list here. And all of these have something in common, besides the fact they all equal 17 pi over 12. If you said that's what they have in common, absolutely. But there's a strategy that you can see built into the numbers. Every single one, the green one, the purple one, the two blue ones, the red one, and the orange one, what do they have in common? And if you see what they have in common, you will break down the strategy, which then makes all your pi over 12 questions extremely easy. What do all 6 of those have that's the same?
All of them have the pi over 4.
All of them have a pi over 4 somewhere. Which means, if you pick a random pi over 4 that we haven't used yet, right? What's coterminal with 3 pi over 4? 11 pi over 4. Okay? So I'm going to pick 11 pi over 4, which we haven't done yet. And underneath it, I'm going to change that to, well, that would be 33 pi over 12. Agreed? What would you have to subtract off 33 to make 17? 12?
16.
16. What does 16 pi over 12 reduce to? You divide it by 4, right? 4 pi over 3. Is that on your pi plate?
Yeah.
Absolutely. There's another one. So the trick is you can use any pi over 4, once we recognize they all have pi over 4, in these questions, you actually don't have to think much. I'm sorry to disappoint you. You can use any pi over 4 you'd like. If you change whichever pi over 4 you'd like to pi over 12, then figure out what you would need to get 17. Whatever that is will perfectly reduce every single time to be on your pi plane. That doesn't happen with pi over 6 or pi over 3 families. It has to happen with the pi over 12 family. And the reason it has to use the pi over 4 family, and I gave a little hint here, is the pi over 4 is the only one when you make it over 12 that's actually an odd number. And your entire pi over 12 family will always have an odd number on the top. Because if it was an even number, it would reduce to a pi over 6 family and no longer be a pi over 12 family. So I can choose any one of those ones we just figured out. I happened to choose 21 pi over 12 minus 4 pi over 12. So what you do is start with pi over 4 family. Here I have them listed. Personally, I would probably start with the 5 pi over 4. I like adding better than subtracting. I don't know why I chose subtracting in this one. Probably so I would be less biased. Because after this, I'll probably always add. Because I like it better. Doesn't matter, adding or subtracting. But choose, some people always just choose pi over 4. They're like, I'm just going to start with a little one. What would you have to add to 3 to get to 17? You'd have to add 14 pi over 12. So step 1 is choose any one of your pi over 4s to go there, and then just figure out what would work to make 17 in this case. If I chose 21, I would have to subtract 4. Then when you reduce that, those two are always going to be on your pi plate. If you start with something other than the pi over 4 family, when you reduce, it's not guaranteed that they'll both be on your pi plate, and then you'd have to start again. But choosing the pi over 4 will always work. And it doesn't matter which ones you choose. When you do your alpha and beta, and then go to your alpha and beta formula, it'll always simplify to be the same thing in the end. But now we have to be a little bit careful from our pi plate. 7 pi over 4 is in quadrant 4. So cos will be positive. It'll be root 2 over 2. Cos of pi over 3 is 1/2. Sine of 7 pi over 4 will be negative because it's in quadrant 4. So it'll be negative root 2 over 2. And sine of pi over 3 will be positive root 3 over 2. And once again, when we multiply our numerators and multiply our denominators, we get a root 2, a root 6, and a 4, but this time the root 6 was negative. Sometimes on the final exam they have a part B. to a question like this. Part A, they say calculate cos of 17 pi over 12. And then in part B, they say calculate secant of 17 pi over 12. So if you knew cos of 17 pi over 12 was this, then secant of 17 pi over 12 would just be the flip. And you just need to flip your answer. They almost always do this as a part B now, because it used to be on the exam, sometimes they would just ask secant of 17 pi over 12, and so many students would just leave it blank. Because if you don't know to first figure out cos of 17 pi over 12, then you're screwed and have no idea how to do the secant. So now they usually add that as a part B. I'm going to get you to write down this exam question and circle number 7 for practice.